So now I'm going to tell you about peptic ulcers. And my little bacterium here is in the way. But this little bacterium is called Helicobacter pylori. Let's see if I can give it some more room. There we go. Helicobacter pylori. First, there are two different types of ulcers. There can be gastric ulcers and there can be duodenal ulcers. Both gastric and duodenal are considered to be peptic ulcer disease. If a person has an ulcer in their stomach itself, gastric ulcers, it is from failure of the stomach to protect itself from the acid. And I'm going to go through some of these protection factors. If it's a duodenal ulcer, it is usually from a lot of acid secretion, too much exposure in the duodenum to this acid. Either way, a bleeding ulcer means it cuts through the mucosa and it ends up cutting into the submucosa, which is where we have blood vessels. And that means the person is going to start oozing blood into their stomach or intestines. And this blood will be digested and it can cause vomiting. If the patient is vomiting blood, oftentimes they're going to think, and you got to coach them with this properly. If you say, "Are you vomiting?" and they say yes, and you need to follow up that question, because most of the time a patient will think vomiting blood means occult blood, meaning fresh, bright red. And that is usually, if it is bright, fresh red, it usually is indicative of an esophageal tear. Maybe they're vomiting a lot. But if they have an ulcer wound in their stomach and it's bleeding, their vomitus, is going to look like black coffee grounds. That's what it's going to look like. So you have to say to them, "Are you vomiting?" "Yes." "Can you tell me what your vomit looks like?" Let them tell you what it looks like. Now, similarly, if it's a bleeding ulcer in the duodenum, the person probably is going to have a unique presence of their stool. And their stool, again, is going to be indicative of blood being digested. And so you're going to say to them, "Does your stool look normal?" And most often than not, they will say no. And you're going to need to say, "Can you describe it to me?" And usually what they will describe it as very thick, very black and tarry, very sticky, very difficult to clean up after. And that type of stool is called melena. That's what it's called. So let's go through the protective factors. Here is your stomach and duodenal mucosa. And the mucous neck cells are going to produce bicarbonate-rich mucus. The bicarbonate is there to help neutralize the stomach acid. Again, parietal cells release the hydrochloric acid. They also release intrinsic factor, just to remind you from lecture unit 1. There are prostaglandins that are there to help with this mucus, bicarbonate-rich mucus. To be specific, it's prostaglandin E2. Now, I'll remind you, prostaglandin E2 is also the prostaglandin that is made to help with thermoregulation when we take an NSAID or Tylenol. Prostaglandin E2 is also important for softening a woman's cervix before labor and delivery. But prostaglandin E2 is also important for the synthesis of this gastric barrier, is what we call it. So we need good blood flow in order to make this mucus. We need growth factors, and the reason why we need that is because these cells, simple columnar cells, are highly mitotic. There is fast turnover. The idea is they're getting exposed to this acid and the pepsin. We want to replace them. newer, healthier cells. Plus, they have tight junctions. That means neighboring cells are kind of stuck together like glue. And that prevents backflow of the acid in between the cells into the submucosa. What can damage it? Stress. I know all of you right now are going, I feel like I have an ulcer coming already, just learning about this. Smoking, alcohol, those are the big three. NSAIDs, probably a close runner-up for fourth position. And then lastly, H. pylori. H. pylori is a bacterium, Helicobacter pylori. And if we rule out these other damaging factors, we can't rule out acid and pepsin, that's just natural what the stomach secretes. But if we rule out stress, smoking, and alcohol and NSAID abuse, H. pylori is probably the culprit. And this bacterium is very difficult to treat because it is used to living in a very harsh environment. In fact, most of the time, there needs to be at least 2 different antibiotics that are prescribed and also antacids, because the antacids will change the pH in the stomach, making it less acidic, more towards basic. And that kind of gets the H. pylori knocked off its pedestal a little bit. Easier to go after it. But for these are the number one issues. Especially when we're talking about having all 3 together. A lot of people who are under stress might self-medicate with alcohol. They might also smoke to help with their nerves, etc. Interesting fun fact, how many of you have taken micro already? Yeah. Did you learn about H. pylori? You think so? Did your professor tell you the cool story about the person who linked, the scientist who linked gastric ulcers with H. pylori? No. The scientist that was studying them was convinced that if we rule all this out, this bacterium was in fact the culprit for starting gastric ulcers. And to prove his point, he actually consumed H. pylori to induce an ulcer, just to prove his point. Now that's taking your work home with you. That for sure is a dedicated scientist. How can we help someone who does have peptic ulcer disease? Well, we have a few tools in our toolkit. Antacids. Antacids can help neutralize the excessive acid, but sometimes they're not enough. Like I said before, if it is H. pylori, we're going to give antacids and antibiotics. We also have some medication. Many of them now, I shouldn't say many of them, but one of them, a big one, is Prilosec, omeprazole. And it's now sold over the counter. You do not need a prescription for it. And omeprazole, Prilosec, blocks this hydrogen potassium ATPase, which is on the apical or lumen side of your stomach. So omeprazole blocks that, and that is the originator of where the acid is coming from. We also can give histamine receptor blockers, the histamine receptor blockers like Tagamet or Zantac. And then lastly, we can actually do surgery and remove the antrum of the stomach. And that is where we find a lot of these gastric glands that are releasing from the G cells gastrin hormone. Take out that section and you're knocking down the one biggest contributor out of the 3 of stimulating acid secretion. We can go after another stimulator of acid secretion. We can go after the vagus nerve, and we can cut it close to the stomach so it does not impair heart function or lung function, but we can do that as well and cut out at least the acetylcholine branch. So those are our options. We're moving on to the small intestine. And I need to remind you of the anatomy of the small intestine. There are 3 features that increase the surface area in the small intestine, not just for more mechanical digestion, but also for chemical digestion, enzymes. The macroscopic folds that you can see, especially if you cut open the small intestine of one of the cats that we use in the anatomy class, are the plicae circulares. Plicae circulares. And they act a lot like, ever look inside the drum of your dryer? Ever notice that it has little plastic inserts and it makes your clothes tumble? Otherwise, they would just stick to the sides of the drum. So that means they're tumbling and they're getting exposed to more of the warm air, and your clothes dry faster. The plicae circulares do a similar thing. They make the chyme. The chyme is the digested food that just came from your stomach and is now in your duodenum. So they make that chyme tumble around. It leads to more mechanical breakdown, getting it more mushy. And it also helps with mixing it like a cement mixer with the digestive enzymes. Lots of mixing. A lot like, if you were making cookies or something. You don't just want to put in all the ingredients and not stir it. You got to stir it all together. Otherwise, you're going to have some poorly formed cookies. Then we have villi. Villi are these finger-like extensions. And when you were in anatomy, did you see the villi model? It looks like Patrick's star. Do you remember that? I mean, it really does, like the starfish from SpongeBob SquarePants. Villi also increase the surface area for more digestive enzyme exposure. And then on top of the villus, we have the simple columnar cells, and they have microvilli, little extensions of their cell membrane. Now, if you've heard of celiac disease, gluten allergies, non-tropical sprue, those are all pretty much synonyms. What happens is the person's immune system attacks the surface, the microvilli that are on top of the villus. And when it is attacked, this gives a lot of surface area, like I said, not only for digestion, but for absorption of nutrients. If those little tiny structures are attacked and destroyed, we lose a big contributor to the surface area. And if the person eats gluten, and it's a protein in wheat, if they eat it and they have this allergy to it, that's when their immune system attacks anywhere it's stuck to in the intestines, most notably the microvilli. So now the person has lost their surface area for absorption, and that means they're going to start having some pretty bad diarrhea, really bad, because they can't absorb it. The particles stay in the lumen, and if particles cannot move, what will? What will? If particles cannot move, what will? Water, good, water will. And so the water follows those solutes that normally in healthy individuals could be absorbed, but now they're not, and it pulls the water, and the person has really bad diarrhea. They're miserable. It used to be that you couldn't really find a lot of gluten-free foods, but now it seems to be all the rage, isn't it? Gluten-free, gluten-free. And a lot of people think, oh, it must be healthier. Well, it's not necessarily healthier if you don't already have a gluten allergy. And a gluten allergy is different than a gluten sensitivity. Some people are sensitive to it, but they don't have this severe reaction to it. So it is not necessarily healthier if you don't have this sensitivity or allergy to it. It just means that if you're buying gluten-free stuff, it probably is a little bit more expensive. And with the cost of money being so high these days, if you don't need to buy it, I say don't. Go for a cheaper alternative. It's just a protein. Still in the small intestine, we have intestinal glands. And 3 of these 4 glands I'm going to tell you about actually release a hormone. Secretin is secreted by S cells. Cholecystokinin and gastric inhibitory peptide are released by other cells, like I cells and K cells. I always remember, get the gist of this. I know, stupid. But they are enteroendocrine cells. That is what they are. Single cells that release these hormones. What will the hormones do? Secretin. Think S for secretin and S for slippery snot. Secretin will target the pancreas to release a lot of bicarbonate-rich buffer. Then we have, specifically mucus, that's why I was saying snot. Cholecystokinin is going to target 2 places. It targets the pancreas to release digestive enzymes, and it also targets the gallbladder to release bile. I'll remind you, the gallbladder does not produce bile. That comes from the hepatocytes in the liver. The gallbladder merely stores and concentrates the bile. Then we have gastric inhibitory peptide. Now this is interesting because at first glance, its name tells you gastric inhibitory. Okay, we're going to inhibit the stomach in some way. and it does. It targets the G cells and tells them, hey, take it easy. Don't release so much gastrin. We don't need all this acid. Enough is enough. So it's finally a way of getting negative feedback inhibition. But now it has another function associated with it, and it's pretty neat. It's called glucose-dependent insulinotropic peptide. They're trying to keep with the GIP, and that was a big stretch for them to do that. Glucose-dependent insulinotropic peptide. And let me give you a real clinical application of how this works. When food hits your stomach or your intestines, the physical contact of food in those places stimulates a lot of these cells to release their secretions. Makes sense. Don't release all these hormones and secretions unless there's food there to process. Kind. Okay, so I'm going to be telling you about diabetes. And I'm going to tell you about type 1 and type 2, but I'd like to tell you about type 3, or other as it's called. One of the types of diabetes that can be found in the other category is gestational diabetes. Gestational diabetes, we don't really know the full cause of it. We just know that the woman's body does not respond to insulin as well as it should. Not all women end up getting gestational diabetes, but if they do, it is considered to be a high-risk pregnancy. And they will not let that fetus go over the due date. They will not. They will induce labor if they have to. The reason why is because if the mother does not get her diet into check, the baby the fetus can gain so much weight from the excessive glucose in mama's bloodstream that no longer is the head and shoulders the biggest part, but now you've got a big thoracic cavity and abdomen. So it's a high-risk pregnancy because we're afraid of the baby getting caught in the birth canal and a difficult delivery. So that being said, glucose-dependent insulinotropic peptide became my friend when I had gestational diabetes. I did not have gestational diabetes with my first child. I did have gestational diabetes with my second child. And we think it's because the pregnancy hormones interfere with the metabolism of the insulin hormone and the upregulation or insertion of the glucose carriers. That's our supposed thought. So women have to take this glucose stress test. And how many of you in here have had babies? Okay, did you have to drink the icky, syrupy orange drink? Yeah? It's nasty. It is, it's just overpowering, like, sweetness. Think McDonald's orange soda, but more syrup. Like, just, ugh. And you have to drink, you gotta chug it. You have to chug it because they need you to consume it all within a quick amount of time, and then they draw your blood within so many minutes. And you're going to be there a while because they take a baseline, then they take it after you drink they're going to tap into both arms. I'm just telling you, they are. It's super fun if you don't pass that glucose test. So they'll analyze it, and I got the call. Yep, it confirmed that you have gestational diabetes. And I remember distinctly where I was when I got the phone call. I was working as a postdoc, and I was doing microscope work in the dark room, taking pictures, and I'm on the phone like this while looking through the microscope. And the nurse says, you have gestational diabetes. We need you to come back in. And she said, it's just a little bit. It's just a little bit, but we don't care if it's just a little. You pass the line, you have gestational diabetes. And I said, well, this does not make sense to me. I am one of 5 women pregnant on my street. Like, that's an argument. And I said, I exercise, I'm healthier than the rest of them. They don't have this. Why do I have it? She said, you must be over age 35. I said, I am not. She then said, you must be Hispanic. No, I'm not. You must be African American. Nope. She can't see me through the phone. I get that. Then she said, and this was the kicker, you must be under a lot of stress. And I went, there's the winner. Absolutely. I was working on my postdoc and then teaching at 2 different schools, community colleges at night. I was definitely busy and stressed, and I already had a toddler on the ground. So yes, I had gestational diabetes. To get back to GIP, I had to go and meet with a dietitian. And the dietitian not only told me what to eat and how much of it. Did you have gestational diabetes too? No? You passed the test? Yeah. But she also told me the order in which to eat your food. And she also said, this is not just for diabetes. Everyone should be eating like this. And I said, really? She said, you eat your fats first. Eat your fats and protein first. She was a genius because the physical contact of those foods will get GIP released, and that goes to the pancreas and says, food is coming, prepare. And that means insulin, before you even get to your carbs, is already starting to spike. There are 2 waves of insulin release. And so that initial wave is coming from the physical contact. So eat your fats and proteins first. Save the tortilla chips and the bread sticks until last, which is so hard to do, isn't it? Because you're hungry, and they bring those out for you to snack on. And try and say, can you just bring it with my meal? Start with your fats and proteins. The other thing, do not buy fat-free dressings or fat-free products, especially if you have problems with your blood glucose levels, because they supplement the lack of fat with more sugar. So eat the fully loaded fat salad dressings. The other thing she told me was what a serving of a carbohydrate is and how many of them you should have throughout the day. You should have about 4 to 6 servings of a carbohydrate. But the idea is not all at once. Not all at once. So what is a serving of a carbohydrate? It's about 15 grams. Probably if you ate one of those, if you look on the wrapper, I bet you it's at least 2 servings.
1 serving.
Okay, is it because it's supposed to be individual? How many carbs does it have?
85.
Okay, negative. That is not 1 serving. Total carbs, 33 grams. And that's not even the fiber. Fiber doesn't count. It is a carb, but it doesn't count. So total carb, 33 grams. Things like this, they say 1 serving because it's individually wrapped. But it's really not if you look at the label, which is heartbreaking. So you're like, it is. It's just a single one. It's just one. It's for one person. Yeah, you're probably going to have to break that too and share it. Or eat half of it and save the other half for about 3 hours later. Who does that? It's very hard to do that. You go to Costco, they have delicious pink grapefruit. Oh, it's good. It says 1 serving because it's an individual cup, right? If you read the label, it's got 2 servings, really, of sugar in there to sweeten the pink grapefruit. Who does that? Who eats half of that cup? It's already just this big. Who eats half of it, drinks half of the juice, and puts the plastic lid back on ever so carefully and wait another 2 to 3 hours? No one does that. But I had to. It's hard. Plan your 4 to 6 carb servings scattered throughout the day. And you should be eating every 2 hours. Every 2 hours, you should be putting something in your stomach. One of those carb servings. So what does a serving of rice, cooked rice, look like? Take a spoonful of rice that can fit in the palm of your hand. That's a serving of rice. If you go to a restaurant that serves Spanish rice and beans, it is a plate the size bigger than your head. You probably, if you add the chips, if you add the rice, if you add you're probably looking at 2 days worth of carbs that you're ingesting in one meal. But most of you can handle that. You have a healthy response to insulin. I'm just telling you how we're supposed to eat. When you come home at night and you're really hungry after work, and you know you're going to make a healthy meal, but what do to tide yourself over? Oh yeah, you go to the pantry and you get out the wheat thins. I thought a serving of wheat thins was the box. Like the entire, no, it's 4 to 6 crackers. That's it. That's enough to tease. And oh, by the way, not that you should do this when you're pregnant, but if you do have diabetes, a serving of alcohol counts. Wine counts. I know. Everyone's like, well, what's a serving for wine? You know those itty bitty baby teacup sets of, the Dixie cups that you have at the dental office for you to rinse your mouth? That's a serving of wine. I know. I'm just saying. That's what. Ironically, harder liquor does not have as many carbs associated with it, but it still does. And I have an uncle who is diabetic, and he will save some of his carbs for at night so he can have his glass of wine. A respectable pour for a glass of wine. Bread. What does a serving of bread look like in carb world? Most people would say at least a slice. Nope. Let's entertain making a grilled cheese sandwich. How do you make a grilled cheese sandwich? Do you take two slices of bread with the cheese melted in the middle, cut diagonally as per protocol? Yeah? A serving of bread, wheat bread, take a slice, cut off 1/3 of it, put that back in the bag. The remaining 2/3 is roughly a serving. Again, how do you make a sandwich? Don't you usually take 2 slices? Or on a really good day when you're trying to be mindful, you take just 1 slice and cut it in half to make your sandwich? Again, enough to tease you. How many of you are cutting off 1/3 of your bread slice? You're not. You don't have little pieces, 1/3 strips, which you could dunk in batter and make French toast sticks. But all that sugar is going to add more carbs, isn't it? I know. Who knew? So if you eat a sandwich with 2 slices of bread, you're actually getting 3 servings of a carb in one sitting, and that's not counting anything else that you're putting on it. Is this like a knife through your heart right about now? So you need to pack your snacks. I try and bring you healthy snacks. I try and bring you protein options. But we're supposed, all of us are supposed to eat that way. That's what the dietitian said. And then we have the duodenal glands, which release even more bicarbonate-rich mucus. Maltase, lactase, sucrase. Do not memorize what those 3 enzymes break into what. I don't go after that at all on the exam. What you should know is that they're color coordinated to an earlier slide that I showed you. They are all enzymes that are going to break down sugars into more monomers, basic sugars. So they are an amylase type of enzyme. Peptidases come from these intestinal glands. Peptidases break down peptides into smaller singular amino acids. Intestinal lipase, remember last week we talked about lingual lipase and I said it's there, but it's negligible, its activity level. But intestinal lipase definitely has a good robust activity, and its job is to chemically hydrolyze your fatty acids into smaller portions that can be absorbed across the intestinal lining. So triglycerides into free fatty acids and monoglycerides. Enterokinase is an enzyme whose job it is to activate enzymes coming from the pancreas, which I will cover, I think, in the next slide. Enterokinase, its job is to activate trypsinogen into trypsin. And then trypsin can activate its dancing partners, as I like to call them, chymotrypsinogen into chymotrypsin, and procarboxypeptidase into carboxypeptidase. All 3 of those, trypsinogen, chymotrypsinogen, procarboxypeptidase, are zymogens. That means they're made in an inactive format variety, and then they have to be activated. They have to be cleaved in some way. This is not the first time we've heard this. We heard about this for clotting factors. Many of them are zymogens as well. We heard about this for pepsinogen, made by the chief cells in the stomach, converted into pepsin with the release of hydrochloric acid by the parietal cells. That's the wrong one. So here, The pancreas is actually about 98% exocrine, which means it has secretions that are released into a duct, shown up here in the top. This is the pancreatic duct. And the enzymes it releases, or the substances it releases through that duct, include sodium bicarbonate under the influence of secretin, zymogens that break down proteins like trypsinogen, chymotrypsinogen, procarboxypeptidase. All of them are going to digest proteins. I'll remind you, protein digestion begins in the stomach and continues in the intestine. There are other enzymes, pancreatic amylase. It also, like the maltase and the sucrase and the lactase that I showed you, is going to break down more complex sugars, starches, into smaller sugars. Pancreatic lipase breaks down your triglycerides into fatty acids and monoglycerides. Ribonuclease and deoxyribonuclease. Any kind of nuclease is an enzyme that breaks down DNA or RNA, and you can reuse those nucleotides for your own DNA and your own RNA. And it's weird to think that, yes, when you're eating food like an apple or a banana, you're actually eating a plant's DNA and RNA. And we can use that for our own synthesis of nucleotides. So the exocrine function comes from the acinar cells. But only 2% of the pancreas acts as an endocrine gland. And this colored part right here is showing you an islet of Langerhans, or in today's textbooks, it is called a pancreatic islet. There are lots of different types of cells there. There's alpha cells, there's beta cells, there's delta cells, there's F cells. I am mostly worried about alpha and beta cells. Alpha cells release glucagon. Beta cells release insulin. Insulin is going to target insulin-dependent cells, IDC. Insulin-dependent cells, the majority of which is skeletal muscle and adipose tissue. There are others, but those are the biggies. Glucagon is going to target the liver, and its name tells you glucose is gone. And the glucagon tells the liver to slowly release more glucose. The liver stores this glucose as a polymer that we call glycogen. That's our way of making starch. Plants make starch, we make glycogen. So glucagon tells the liver, hey, this person hasn't eaten for 6 days, and clearly this person doesn't have Kara as a professor that brings food. We don't want this person falling over in a coma because of lack of glucose for the brain. The brain heavily relies on glucose as a primary fuel source. But insulin is not just for cells to bring glucose in from the bloodstream, the plasma, into the cell for use as a fuel, which is the second part of our lecture tonight. Insulin is also very important for bringing in amino acids. Who knew insulin was for so much more? And another thing that insulin does, it stimulates the sodium-potassium ATPase. And in fact, we can use that to our advantage. If a patient has severe hyperkalemia, we can give them some insulin because that means more potassium will be pumped into the cell, out of the blood and back into the cell where it should be. We try other things first. I'm going to tell you about acid-base balance and what we do about acid-base imbalances, but insulin is not just for glucose management. If a child has a problem with insulin secretion, they also can have a problem with growing because they're not getting enough amino acids to build proteins. So yeah, it's important for more than just glucose. It also promotes fat storage. Told you about glucagon, stimulates the liver, initiates glycogenolysis, that's the hydrolysis of glycogen. Nervous tissue, the brain, is insulin independent. There are other insulin independent cells as well. There is a family of glucose transporters. There's GLUT1, GLUT2, GLUT3, GLUT4. And some cells express a glucose transporter that is there all the time. It is constitutively there, like the brain. So if it just freely takes the glucose from the plasma, and the brain should always have a fuel source. But other cells have these other glucose transporters, and one of them is an insulin-dependent glucose transporter. You don't need to know which one is where, which one is constitutively expressed. I save that for a pathophys lecture, if I ever teach that here. I've talked briefly about diabetes, and we used to call type 1, we used to call it juvenile diabetes or juvenile onset. Can't do that anymore. We also used to call it insulin dependent, meaning the person had pancreatic failure. Can't really do that anymore either. So we call it type 1. Most of the time, it does afflict young children. Most of the time, but not always. Older people can get type 1 diabetes at some later point in their life. We don't know why. It could be an adverse reaction to a medication they're on, or an autoimmune disorder that all of a sudden rears its ugly head. So we can't call it juvenile onset. We also can't really say that it's insulin-dependent diabetes, because not all people with diabetes need insulin. And even type 2, just to prove a point, we used to call it insulin-independent diabetes. There's a lot of people with type 2 that require insulin. So it blurs the lines. Type 1 usually does afflict the youth, but it is not absolute. And if it is in a small child, usually the child has had this diabetes for quite a while before the child gets so annoying that the parent then says, "You're going to the doctor, you've got something wrong with you." The reason why the parent gets annoyed is because the child is constantly eating, they have polyphagia, because their body, their insulin-dependent cells, are starving for glucose. Even though they're eating a lot of carbs, insulin-dependent cells are starving in the face of plenty. It's just right there, but they can't bring it in. The child eats a lot, the child pees a lot, polyuria, and they're getting up in the middle of the night over and over and over again. And then because they're urinating so much, they also want more water, so they're drinking all the time. That's polydipsia. Think of a ladle dipping into water. So 3 polys: polyphagia, polydipsia, and polyuria. And if you combine all of that, your parents start saying, "You can't have any more water after this amount of time because you're now starting to pee the bed." They get really frustrated. Take the child in. Child gets diagnosed with type 1, in this case, in my scenario, and they might need insulin. They might. And that's messy too, because they might not need, they're going to have to do what's called a sliding scale, where they figure out what's the optimal range for insulin for that child. Interesting side note along with that, if a parent this is like a new type of eating disorder. They're calling it no, that's something else I'll tell you about. A new disorder. Kids are going into the refrigerator, teenagers mostly, and getting the parent's insulin, because if the parent takes too much insulin, then they don't have enough glucose for the brain, and the parent starts acting like Fruit Loopy, like they're high or drunk. And there have been some children that go and get this insulin because they think that their parent is getting this high, and they don't realize how dangerous that is. Not enough fuel for the brain means you go into a coma. So that's a problem. Starving in the face of plenty. Hyperglycemia, if we don't get the glucose into the cells, can lead to a diabetic coma. A diabetic can go into a coma for two reasons. Either they're not getting enough glucose into their cells, or they over-injected insulin, and now there's not enough for the brain. So that's when you need to get them some orange juice or something like that. Okay. The machine that you're seeing here is called a glucometer, and I don't know if you know how that works, but when I had to test my blood after every meal, my oldest son, Hayden, he was very sympathetic. Mommy, you have to do it, I have to do it. I'm like, are you sure? It's a little stab of a needle. Yes, I want to know. I want to do this with you. So after I tested mine, we'd get the new strip and a new needle, and he would do the same thing. And I thought, because the package said, oh, you could do it on your arm. No, you can't, even though the package says you can. No, you can't. Have to go for the finger. And man, they get sore after a while. So you start switching fingers and go to the side. Usually the side gives you better bleeders. Anyway, my son thought that was cool to do. Type 2 diabetes, obesity related. Yes, I'm sorry.
No, just going back to how you said that the package says you can do it on your arm, but you said you can't. Like, why is that?
The nurse explained it to me that it is not the best accurate reading of your blood glucose level. And she was right, because when I did it in both places, I got two different readings. And I thought I was like so good with my diet. And like, look, and they track that stuff too. They track it. It's computerized. You bring it to your doctor's appointment, they hook it up, and down comes all the data. So yeah, I started doing that empirical experiment, and it was different. Not hugely different, like by 100 points, but it was different. More circulation flow to the fingertip was how she explained it to me. Type 2, obesity related, as I said. Did I answer your question? Okay. They might need insulin. They might, but they might not. It used to be called insulin independent diabetes. But some of the type 2 diabetics do need it because their body has become desensitized to the insulin. So they need a little bit more to help them with that. Arguably, type 2 diabetes could be prevented. It could be. Arguably, it could be. We used to be one of the most obese nations in the world. We used to. I remember there was a time when we were like number 2. Number 1, and then we got beat by Mexico and we fell to number 2. Now Mexico and the United States are more in the teens because we have the Polynesian islands that are now very, very obese and having a problem with type 2 diabetes. So yay, we're in the teens. So that's good. Children can get type 2 diabetes as well. We have some pretty obese children. And with the obesity, again, they become less sensitized to the insulin. Well, why are they getting obese? Well, there is a factor of reasons. Let's go through this. Most schools have cut down their athletic curriculum, PE, so there goes that opportunity to exercise. At my son's school, both of them, if they wanted PE, physical activity, the teacher said it's a break for us. The parents had to volunteer and lead games and activities with the children. Well, I'm just telling you, that's what it took. I was there every single day playing soccer with the kids or basketball, but we were doing something. So parents get home, kids have homework, parents are tired. Many of you are working 2 jobs, I bet. And there just isn't enough time and daylight for you to go out and shoot some hoops or pass the ball around. It's hard. Weekends, chores, grocery shopping, laundry, cleaning the house. It's a whole weekend reset button. The parents are also tired. They don't necessarily have all the time to cook. They're tired. Healthy meals takes a lot of effort. It really does. So it's easy to go for the pizza or the hamburgers, right? That's the easy part. So there's a myriad of reasons why I think our youth are getting obese and having this problem. And it's not necessarily that they're just overeating. They just really don't have an outlet with kids love to play. They love to play. And not just with another kid. They love it when the parents get involved. My dad, every Saturday and Sunday, he'd go around. He was the biggest kid in my block. He would go around and knock on all the neighbors' doors with kids and say, can so-and-so come play? Can Michael come play? Can Tony come play? And we would play baseball out in the street with bases and everything every Saturday and Sunday. And eventually the kids would come to our house and say, can your dad play? Yes, I'm sure he probably wants to. They just love that. Take them to a park. Climb the ladder up to the slide and go down the slide. Super fun. Especially if you put baby oil on it.
Can you get type 2 without being obese?
Yeah.
Yes, you can. Yes, you can. So anyone can develop an insulin, not an insufficiency, but they are not responding as much to insulin. I said obesity related, just to be fair. Yes. No, there are also drugs that we can give that target the liver. I'm sure you've seen a lot of those commercials and you see the people power walking and I lost this much weight on this drug. And they're targeting this glucose metabolism through the liver, also partly through the kidney. And a lot of people are going for that med because all they really hear is, I lost this much weight. Well, let's take things in perspective. Do you see them power walking down the street? They're exercising. Taking this pill alone is not going to do it. So yes, there are other things we can do. Usually we prescribe them to augment the insulin if they are on insulin. Yes.
What if they are relatively really healthy, they don't really eat necessarily bad stuff, maybe or they eat the average normal person, or they're very active and this and that, and what if they're I wanted to ask what if someone from their family has really had it?
Is there a genetic component is what you're asking? Yeah. There is a genetic component, but most of the time a genetic component accounts, I'll use breast cancer as an example. Breast cancer genes run in families as well. We all know of Angelina Jolie and her mom. Well, people who inherit these bad cancerous genes, they account for about 10% of the entire population of women with breast cancer. 90% are sporadic. I have other examples. Parkinson's disease. There's also a genetic component, but it only accounts for about 10%. The rest is sporadic. So my point is, Is there a genetic component? Yes. But it is probably not passed on from through the generations. Can it? Yes. But usually, no. Someone gets diabetes of any variety, most of the time it's going to be, oh, this is new for our family. And the parents didn't have it. Any other questions about diabetes? There are 3 pathies. I told you about the 3 polys. There are 3 pathies, 3 pathological outcomes. They have nephropathy, the extra workload on the kidneys at the tubular level, the nephron, makes the nephron start dying, really. And then they can't do their job and more glucose spills into the urine. So nephropathy. Retinopathy. Your retina is neurons. And those neurons also start to die from the excessive sugar. So vision starts changing. And the last one is neuropathy. Poor circulation down to the legs and also more glucose. The nerves become less sensitive to pain signals. It's hard to believe that buying new shoes could cost you your leg. You wear new shoes, you walk around in them all day. If they're new and they're rubbing differently, you start to feel the blister forming, don't you? And what do you all do, normal, healthy individuals? You're like, I should probably change the way I'm distributing my weight. I don't have a Band-Aid. I don't have socks, so I'm going to have to let this heal and then keep wearing those shoes to break them in. But an uncontrolled diabetic with this neuropathy, they don't feel that. They don't feel the blister coming. So they just keep walking all day long the same way, making that blister get bigger and bigger. They put the shoes on the next day, keep walking around. Next thing you know, they have an ulcerative wound. Now they need wound care. And because of the diabetes, they don't get good vascular flow. It does not heal very well. Usually they're going to need a home nurse to come and change their dressings and clean it out for them. And if it's not taken care of properly, they get gangrene. And that's when we start cutting limbs off. And that's when the quality of life in that patient starts going down the drain, because they start thinking, well, why even bother? Why bother? They're just going to hack something else off. So their quality of life in their eyes becomes impaired. Do you have any other questions about diabetes? It's one of our biggest healthcare crises, and also very expensive. It's a lot of money that goes into diabetes prevention and treatment. One more slide and then you'll have your quiz and your break. The large intestine. The chyme enters into the large intestine, into the cecum, through the ileocecal valve. Its name tells you it is the division between the ileum, the last part of the small intestine, and the cecum. Now you don't have chyme. It is not food anymore. It is feces. The only thing that the large intestine is really good at is reabsorbing more water from the feces, which sounds like it's really good. You don't have a runny stool then. Well, if it is sitting there too long because you don't go defecate often enough, your feces can get so dehydrated, if you will, because, and here's why, mucin is the product that is released by the mucous neck cells. You have to add water to it to make mucus. But if you are not having enough water in your large intestine, then that feces can get impacted. And then you start having issues with the fecoglyph, which means poo stone. That's what that means. And they're very hard to get out of your body. And I'm telling you, if you have a patient on bed rest for long term and they're not getting their fluids just right, they're going to have a hard time passing. You're going in there. I recommend double gloving because you're going in for a digital extraction. That is what you're going to do. Okay, so more water reabsorption, but also electrolytes, and also in our intestine, we have some bacteria that help us with certain vitamins, vitamin B complexes, also absorbing a little bit of vitamin K. Interesting fun fact. Animals like horses, if you take out their appendix, they won't be able to make their vitamin K. They won't be able to live, and that means problems with clotting factors. We can have ours removed because we have these bacteria in other places that can help with the vitamin K. All right, you ready for your quiz? Come on, it's open note, open book. These quizzes are fun for me because I realize, I know I spoke the words, I know I tried to put things in context, and it's like, by the time you get to the quiz, your head is down. You're so tired. So let me pull up the quiz. You've had it all along. You can find it underneath the autonomic nervous system PowerPoint. It is slide 11 and 12. Yep, you don't need to write down the questions. There are 5 bullets. You can just do parasympathetic, 1, 2, 3, 4, 5. And on the next slide, there are 5 more for the sympathetic division. Well, especially if it's open note, open book, and you can do it with partners. If you do have partners, please make sure I get one piece of paper with everyone's name on it. Please, please, please. You don't have to, though. Respect their boundaries if they don't want to be with you. Well, it's true. It is for credit only, and you can get up to 5 points. Wait, what? Who? What? Where? That you can't live without? You can live without some parts of your small intestine. It depends on how much we're taking out. You can also live without parts of your large intestine. But if you take out huge sections of the small intestine, you lose some of that area for absorption.
More of a partner, right? Because you can just get a colossus.
No, you can resect both of them. Some people don't want that bag to, have you watched YouTube channels with some of the people, young people too, because they had Crohn's disease. And bless their,
Yeah, I follow a fitness influencer, he's like very positive about it.
Yeah, and they have such a great attitude. They're like, this is better than the pain I was going through. It's like, I would make the same decision. It's in the autonomic nervous system, slide 11 and 12. I also have more pencils up here in my little jar. And a student gave me some pens because she said, you're always buying us pens, so I got you a package of pens. I can't even look at them. Can't even, no. It was very thoughtful of her, but I can't. They have a cap. I can't do it, you can't do it. But free school supplies is still free school supplies.